In this video, we're going to focus on some physical problem that will help us determine the force and coefficient of friction from a given body. So let's start with this problem. A body of mass 100 kg is placed on a rough horizontal floor. If the body is moved at a constant speed by applications of horizontal force of 500 Newton, calculate R1, say the force exerted by the flow on the body, R2, say the coefficient of frictions, while acceleration of free fall G is equal to 9.8 meter per second squared. So guys, let's start with our solution in solving the problem. On our solution, we firstly draw our free body diagram. Free body diagram. This is our free body diagram. Okay, this is the center of the body. The horizontal force on the body was 500 Newton. So the 500 represents F. Okay. Now, R1, the force exerted by the flow on the body. What will be the force exerted by the force on this particular body according to our diagram? So say from the diagram, from the diagram, R is equal to the mass times the acceleration of free fall, which is gravity G. Now, this R represents the force exerted by the flow on the body. This is the force exerted, and we also call it the reactive force or the reaction of the body of the force. So it's equal to mg. And then why the mass in this problem? If you look at the problem, our mass is what? 100 kilogram. This is the mass, okay? So that means in place of m, we're going to put 100 times g. Why the g? And the g represents the acceleration of free fall, which you got 9.8. Okay, so if you multiply 100 times 9.8, you get 980. Since we are looking for force, it will be 980 Newton. So this is our force exerted by the flow on the body, which is 980 Newton. Kind of I2, the coefficient of our frictions. Now, if find the coefficient of friction, we say the force F is equal to the coefficient of friction times the force exerted by the flow on the body. So now we're going to solve for the coefficient of the friction. So divide both sides by R, divide both sides by R. So R and R cancel. So therefore our coefficient of friction will be equal to the force divided by R. Okay, but our force F according to our problem is equal to what? 500 Newton. 500 Newton. So say therefore our coefficient of friction is equal to 500 Newton divided by the force exerted by the flow on the body, which is 980 Newton. So Newton and Newton cancel. So our coefficient of friction U will be equal to if you use a calculator, you simply get 0.51. Please know that the coefficient of friction have no unit, so you remain that